In this video, we are going to talk about naming alcohols in organic chemistry. So let's start with a simple example. CH3OH. What is the name of this alcohol? So the Iupac name is going to be methanol. You need to be familiar with the list of names. So if you have an alcohol with one carbon, it's methanol, and then 2 is ethanol, and then it continues with propanol, butanol, pentanol, hexanol, heptanol. There is also octanol, nonanol, and then decanol. The next example is going to be this. How would you name this alcohol? So we have 3 carbon atoms, so it's going to be a propanol. But the OH, or the hydroxyl group, is on carbon number 2. So we're going to call it 2-propanol. Now for the next example, let's look at one that's a little more difficult. How would you name this alcohol? So first of all, we have to number it. We can number it from right to left in this case. So 1, 2, 3, 4, 5. But notice here that it looks like this is the main chain, right? This looks like the longest chain. However, if we count like this, we can see that this chain actually has 7 carbons, while this one has 6. Even though this one looks like it's the main chain because it's drawn like this in the bond line structure, this ending only has 1 carbon and this ending has 2. So that one is going to be the longer chain. So that's your main chain. And so we have a methyl on carbon number 5, and we have 7 carbons, so that's pentanol, and our OH is on position number 2, carbon number 2. So we're going to write 2-heptanol. Let's look at another example. So let's say we have, sorry, I was doing it with my eraser. Let's say we have this compound. How do we name this? Well, we know that we have one. Okay, my computer is bugging out. Well, we want to count it so that the OH number is the lowest. So we don't count from, we could count from right to left, but you could see that the OH is on carbon 4. But if we count from left to right, the OH is going to be on carbon 1. We always want the OH to be on the lowest carbon possible. So we go with the red way of counting, in this case from left to right. Now we have 4 carbons, so this is going to be a butanol, and our hydroxyl group is going to be on carbon number 1. So this is going to be a 1-butanol. The next example, let's look at a small compound. So let's say we have how would you name this alcohol? So we have 2 carbons, right? We have 1, 2. and we have a hydroxyl. So if you have 2 carbons in an alcohol, that's going to be ethanol. But you could say, hey, look, it's not just ethanol, you have the hydroxyl on carbon 1. Well, you don't really write 1 ethanol, because even if the hydroxyl was in the other group, in the other carbon, it would still be 1 because you could just count the other way. So it's not really going to make a difference in ethanol, so you don't really put a number for that. Now let's try an example where we have 2 hydroxyl groups. How would we name it if it was like this? So we can count from right to left or from left to right. In this case, it doesn't matter because the molecule is symmetrical. So we can just go right to left in this case just because. We have 7 carbons, so that's, that's heptanol. However, we have 2 OHs, so it's actually going to be called heptane diol. And in terms of the numbers, it's going to be 1 OH is going to be on carbon 3, the other one's going to be on carbon 5, so it'd be 3,5-heptane diol. If it was 1 carbon, it would be heptanol. But basically what you're doing is you're taking away the OL, adding an E, and then putting the suffix, really the prefix DI, and then adding the OL back in. Let's try an example that has a halogen. Let's try fluorine. How would we name this compound? So we could count from left to right to give more priority to the fluorine, but we're actually going to count from right to left because when we have an alcohol, it's part of the name of the parent chain, so we always prioritize the alcohol group rather than anything else, whether it's methyl or halogen in this case. So we have 4 carbons, which would mean that it is a butanol, and the alcohol is on carbon 1, so it's going to be a 1-butanol. And we have a fluorine on position 3, so it's going to be a 3-fluoro-1-butanol. Let me draw that a little more crisp. How about this example? What would you do here? It really doesn't matter which direction we count it because the hydroxyl is always going to be on position 3. But it turns out that the chlorine and the fluorine position actually does change. So let's try it both ways. Let's try counting from right to left and from left to right and see what the difference would be. So if we do from right to left, chlorine is going to be on position 2. So we would write 2-chloro, 4-fluoro, 3-pentanol. And the reason why we put chlorine, the chloro, before the fluoro is because we always want to alphabetize it. So we want the C to be before the F because C is before F in the alphabet. If we do the way we counted in the red, it would be the same thing except that chlorine would be on position number 4 and fluorine would be on 2, as opposed to it being the other way around. So we would write 4 chloro, 2 fluoro, 3 pentanol. Which one of these would be the best answer? The one on top is in increasing number order. The one on the bottom is decreasing number order. If possible, and if it's not going to mess up our alphabetical order, we always want to go with the one that is increasing number order. So 2 chloro, 4 fluoro, 3 pentanol would be the best answer here. Now, let's say that we have one, we're given a condensed structure. What would we do first in trying to figure out the name of this compound? So the first thing I would do is draw the bond line structure. So we have 1, 2, 3 carbons, and then we have an OH hydroxyl on the right, and this is called a methoxy group. So we can just write it out like this. Now, when we count, we don't start from the left because we want to prioritize the OH, so we count from the right. So we have propanol, and more specifically we have 1 propanol because the alcohol is on position 1. So I would start with on the right side with 1 propanol, and in terms of substituents we have, I could draw this a little better actually. You could draw it like this. So yeah, that's my mistake. The methoxy is on carbon 3. It's attached to carbon 3. So we would write 3 methoxy, 1 propanol. That's how we do this one. Now let's say we have a cyclic alcohol. So cyclics would be, we've seen normal chains like this, but what if we have where it's a closed chain? So that would be a cyclic molecule. So let's take the example of this one. How do we name this compound? So we know that we have 4 carbons because we have 1, 2, 3, 4. Right? Each corner is going to be a carbon. And so we know that this would be butanol because we also have an OH. Right, we have it here. However, since it's a cyclic molecule, we're going to call it cyclobutanol. Now, when you only have one substituent on a cyclic molecule, it's not really going to have a number because we assume that the OH is going to be on position 1. So we don't need to write 1 cyclobutanol, we can just write cyclobutanol because there's only one substituent. However, what if you had a cyclic molecule with more than one substituent? So what if you had something that looked like this? Would we start counting like this? Or would we start counting like this? We want to do it the red way because we always want to make sure that the hydroxyl group, the OH, has the lowest number possible. and the lowest number possible is obviously 1. So this is cyclohexanol because it has 6 carbons. And on position 3, we said the red one was correct. There's a propanol substituent. So since it's position 3, we're going to write 3-propanol cyclohexanol. Now you might be wondering, actually that's wrong. It's propyl. You might be wondering why we don't write the 1 for the OH. Once again, it's assumed that the OH is going to be on position 1, and you just need to know that the propyl is 2 carbons away from the hydroxyl. For our next example, let's take a look at another cyclic molecule. This time we have bromine. Here's our alcohol group, and then here's an ethyl. How do we name this one? Well, as we said, we always want to prioritize the OH group, so we start counting at the hydroxyl, so we say 1. But what do we do here? Do we go this way, counterclockwise, or do we go clockwise? So if we go counterclockwise, the bromine is going to be at 3 and the ethyl is going to be at 5. So it'd be 3, 5. If we do it clockwise, then the ethyl is going to be at 2 and the bromine is going to be at 4. Since 2 and 4 are lower than 3 and 5, we're going to go with the blue option. So we're going to go with the clockwise option. So we're going to do like this. And you could even tell because after you number the first one, the next substituent is right after, as opposed to it being 2 carbons away. So that's how you can tell that the blue is the correct way just off of a shortcut. So since we have 5 carbons in a cyclic molecule, this is going to be cyclopentanol. And then at position 2 we have an ethyl. And we write the ethyl first because it's first in the alphabet, so 2-ethyl. And then we have a bromine at 4, 4-bromo. And it really shouldn't be capitalized. I wasn't trying to make it. This portion should be one word. So that's all I have for this video. I hope it was helpful. Leave any comments you have in, well, comments or questions in the comment section. Thank you for watching.